Hello and welcome everyone to this very first session of this 2025 edition of the World Sustainable Procurement Day, focusing on the nuances associated with the product carbon footprint. My name is Kanish Negi and I work as Sustainable Procurement Director with Schneider Electric, and I'm extremely excited to co-present this session with my partner in crime and extremely knowledgeable Alessandro. Alessandro, it's an honor.
Well, the honor is mine, Kanishk. Happy to be in this session. My name is Alessandro Pistillo. I work for BASF. I'm Director for Sustainability and Digital Strategic Projects, deeply involved in topics around product carbon footprint and the scope 3. So which will be the topic of today. Definitely a fascinating topic. And I always like to say that product carbon footprint is the key metric to show progress on the net zero journey at product level. And it's not just something which is something to do with regulation, but actually it's a really key business factor for companies right now already.
Absolutely. So today, the way we have structured the session is that between us, we'll try to cover the entire topic in a holistic manner, starting with the evolution of why we are even talking about the product carbon footprints, or PCFs, as we like to call it in short, to the prevalent approaches, challenges, and then concluding with what kind of best practices we may expect to adopt in the future course. Alessandro?
Yeah, I mean, let's say that best practice is always nice to be known, right? And nice to talk about it. But an important thing is, do not just aim for perfection on this topic. The topic is really very nascent, and it's definitely important that you move forward and you don't wait for 100% perfection before you start to deal with product carbon footprint.
Yep.
So Kanish, yes, now we will have a brief presentation for us, right? So we split a little bit the topic. I mean, you will hear perspectives from different industries. Kanish will show something related to the experience of Schneider Electric, definitely a pioneer in this space, and what is happening in the capital goods industry. And I will give you the perspective from the chemical industry, and in particular focus on the role of industry collaboration. But have fun. Hopefully will be something you can take with you later as a valuable insight. And Kanish, you're on stage now.
Thank you so much, Alessandro. I hope you are able to see my screen.
I can.
Perfect. So now we all know this diagram. It represents in a very simple manner the different scopes of the GHG emissions. However, if you look at the evolution of the carbon accounting, amongst the corporates especially, it was generally scope 1 and scope 2 that was accounted for via the on-site data or the primary data. And scope 3, both the upstream and the downstream, whenever accounted, they were usually using what I personally like to call it as theoretical computation, either using the spend analysis of the materials purchased or the overall product lifespan, etc., etc. And this was all right when we were in the early stages of carbon reduction journey, and we were still scratching the surface of the issue. But now we know that scope 3 reduction is absolutely essential if we have to make any tangible progress towards our net zero commitments. And this upstream is the sweet spot where procurement has an extremely vital role to play, without which the entire net zero dream would completely fall apart. Now, the product life cycle is actually a vital tool to quantify the carbon footprint of the goods and the materials that we purchase, and then track the performance of the decarbonization. And this directly feeds into our net zero trajectory or net zero efforts. However, in our experience, when we reached out to whom we consider in our supply base as the most mature top 1000 suppliers, we realized that only rough about 30% of them have some form of awareness on the product carbon footprints. Although it's important to mention that Schneider Electric operates probably one of the most diverse and heterogeneous supply chains, which covers materials ranging from raw materials to fabricated components to electrical and electronics to services to solutions, services, softwares, etc., etc. And while we see then some sectors are more prepared to respond to this due to predisposition towards life cycle assessments or by the virtue of being more regulated, a vast majority of suppliers, they are still at the very early stage of this journey. Now, the next important question is why PCF computation is such a challenge. So we will first take a helicopter view, and then in the next couple of slides, we'll zoom in. So theoretically, the computation of PCF appears to be a rather simple mathematical process. You know, you take certain types of data from suppliers, and we'll get into the details of what those data are. But at a high level, you take certain data from suppliers, you multiply them with what we call as certain emission factors, and boom, you have your product carbon footprint. But we are not computing the product carbon footprint just for the sake of reporting or any academic exercise. Although, to be completely candid, life would have been much simpler if that was the case. But as procurement, we need to drive the reduction of the product carbon footprint. And in order to achieve that, we either need to reduce the input data, which is coming from supplier, the values of those input data, or the emission factors which are being used for the computation. Now, look at it as a simple multiplication. You multiply 2 multiplied by 4 gives you 8. So if you have to reduce the value of 8 or bring down 8, you either lower the value of 2 or you lower the value of 4. Now, if we look at the most prevalent and the common approaches to compute the PCF, they rely upon the standard information or data, which typically comes from either a bill of material, product descriptions, the emission factors, etc., etc. And these are multiplied to get the product carbon footprint. Now, the benefit of this approach is that it's relatively quicker in terms of data collection. There are databases, there are data sets for emission factors. We can get the relevant data from the bill of material, etc., etc. So it's relatively quicker, but the challenge is, since it's based on standard values on global averages, any intervention which is made on the site, such as efficiency improvement, adoption of renewable energy, or anything else, it will be extremely difficult to integrate those into these computations. And any reduction in the PCF or the product carbon footprint, in this case, will be driven primarily by fundamental changes such as a product redesign, the substitution of the materials, and we know that those changes, they have their own life cycle. And it's not an ideal situation for demonstrating or computing the PCFs at a massive scale, especially when we are looking at the reduction as our main driver or objective that needs to be achieved. However, the other approach that we have, it relies on collecting and feeding the on-site data into the computations. Now, the benefit of this approach is that any on-site intervention, be it your efficiency improvement, deployment of renewable energy, substitution of materials, from smallest to the big ones, they can immediately be fed into the product carbon footprint computation, which means you'll be able to see the effect of your improvements on site almost immediately. It's a much more agile, dynamic, and a result oriented approach. But why am I saying this? Now, apart from the academic analysis, we actually did some pilot studies over the past year with some of our select suppliers and tested some of our hypotheses. Now, in the first pilot, we picked up 3 components that we purchased and we computed the product carbon footprint twice. Once with what I mentioned as a theoretical approach, taking the standard data, and the other time actually deep diving with the suppliers, taking the on-site data and then repeating the computations. So while the theoretical data, and that's the one that you see on the screen right now, gave us an average reduction of 9% from a 2021 to 2024 performance period for the 3 components. When we fed the on-site data, we actually found the reduction was much higher. It was 77% when for the same period for the 3 components when we actually look at the ground data, the site data, and feed it into the computation. Now, this difference between 9% and 77% can have a very significant impact on our journey towards the net zero, and also how we choose to focus and channel our efforts with which areas, on which suppliers, on which activities to augment. And the key learning and an important lesson that came out of this entire exercise was the theoretical approach discounts a lot of site interventions that lower the GHG emissions. And we must try to get as much on-site data for the PCF computation as possible. Now, of course, there are huge challenges in that, and we'll touch a little bit on those. It has to be a gradual journey. We cannot expect an overnight transition or change. But this is the direction that we should be looking at while we are creating our roadmap and action plan with our partners on this topic.
Kanish, one quick question. There are some people lamenting this prompt of AirMeet that you're sharing your screen. Can you click on hide, perhaps?
Okay. My apologies. Thank you, Alessandro, for mentioning.
Perfect.
Is it better now?
Yeah, now it's disappeared. Thank you very much.
Thank you, and apologies for that. So that was the lesson which kind of came out from the first pilot that we did. We also did another pilot where we took a value chain approach. So not just going to the tier 1 supplier, but we actually went beyond. We went to the tier 2 suppliers. And the idea was to, first of all, anticipate how much effort and energy it takes us. So to size that part, and also identify which lever holds the maximum potential for achieving the reductions over a value chain period. And in here, we did the comparison for a period of 2023 and 24, depending upon the maturity of and the availability of data and specifications with the partners who were involved in this. So in this case, we typically purchase materials from our tier 1 suppliers who are converters. So they take the raw material or purchase the raw material from a tier 2 supplier, and the tier 2 supplier, we reached out to them, we had the engagement, and then we did the modification on the raw materials which arrive at tier 2 and then eventually at Schneider Electric. Now, in this case, we identified that the raw material supplier actually reduced the carbon footprint of the grade of raw material that they were supplying to us by 13% between the period of 2023 and 24. And it really helped because they were able to provide the PCF computation to us, and we were able to have this visibility. Now, when this raw material feeds or is fed into tier 1, and here we took 2 components that we purchase from the supplier rather than 3 as we had in the previous pilot, we realized that there is actually a reduction of 20% which is coming in these components for the same period. So tier 1 tier 2 supplier actually made certain adjustments, modifications, because of which their carbon footprint reduced, or the carbon footprint of the material that they supply reduced. And when that reduced carbon footprint was fed into the tier 1 supplier who actually make the components, it actually led to a 20% reduction for the components that we buy. Now, when we deep dive into the reductions that we achieve, we realize that the interventions at the tier 2, at the raw material stage, were actually responsible for almost 60% of the reductions that we had achieved. And couple of things that came out of this experience was the interventions done at the raw material stage. They hold the most significant lever of reduction for the PCF. And now, of course, results may vary depending upon the sector in which we are operating, the kinds of suppliers, their maturity, but at a high level, it remains the same, that the strongest and the most effective lever for reducing the carbon footprint is the raw material segment, and then followed by the energy or the electricity consumption, and then followed by miscellaneous activities. Now, from this helicopter view, if we zoom in, and if we have to actually do the computation and adapt our approach for the approach number 2, wherein we're talking about getting the on-site data and using it as much as practically possible for our computations. This is all the data that we need. And for clarification, we are referring the packed methodology for our approach, or for defining our approach. So what you see on the side, on the left hand side, is actually the different components of data which are required for a PCF computation. And I will not repeat each of those, but only highlight a few challenges that we face when we come across, or when we start looking at collecting these data from the site. So the first one is that not all the data which is required is actually readily available. And please note that the problem statement here is not so much so as to how we do the computation, but rather a bigger challenge is how do we collect the right data for the computation. Yeah. And we analyze the different kinds of data, and the color code that you see, it kind of reflects what our experience with the kind of sector we operate in gave us the results. So the yellow ones that you see, those are the ones that we find are, let's say, relatively readily available. We can collect them and start using them for the computation. The brown ones, they are the data which could be made available, but the computation, the assimilation, it's a rather tedious and a complex process. So there is a huge effort which goes into that. And then red is the one which is rather difficult to actually measure for the product. So the key challenge here is to get the data at the product level and not at the enterprise or the facility level. Now, think of it as the machines in your facility. If you're having a facility, there are certain manufacturing processes which are going on. You might be having 4 or 5 or different machines which are running. Now, for this kind of analysis, what you actually need is the electricity consumption, and I'm just taking an example out of the various data fonts which are required. You need to compute the electricity consumption at the machine level for each of the products which are manufactured. And if you correlate, and this is what came across in our conversations with a lot of our partners, when we look at the electricity meter, they are typically one single meter at the input point, and that monitors the entire electricity consumption of the facility. Not very often we find instances where companies have meters, sensors, other sorts of infrastructure which can actually track the energy consumption at the machine level or at the process level. And that is what the complexity which comes into when we are talking about collecting the data which can actually feed in to the computation on an agile or a dynamic manner. So starting with the use of standard theoretical data, which will give us quick results, but demonstrating the reduction might be difficult, we have to gradually move towards starting to collect on-site data and feeding into the computation, which will be difficult to collect, but we need to start making efforts on that from now on, because it has its own time period, maturity, efforts, which will be required to get that data. And um, the real challenge is the lack of infrastructure to collect that data. And then there is another point of standardization, the references, the methodology, which I'm not going into in the interest of time, but these are some other areas which we also need to factor in as we move into the journey of product carbon footprint. So just to summarize from a high level, what does an end-to-end process look like? It looks like the first one is to get data collection. The more precise is on-site data, not readily available, go with something which is available, which is standard data sets. But the challenge here is it needs massive capacity building, onboarding of suppliers, mapping the in-scope products, components, people who are responsible for it. And always remember, the problem statement is the missing data, not necessarily the computation part of it. The second step, once we have some form of data with us, is actually the computation. Now, I said the problem statement is not computation, but it's not something which we can ignore, because we need to digitize our ability, our capability to do the computation. Usually it requires huge amount or quantum of data, and there is no practical way that we can do it using manual, Excel, or any other mechanical form. It has to be a digital tool which can facilitate and expedite the entire process. Uh, the next step is, once we collect the data, I mean, the journey doesn't stop here. It has, the supplier data has to feed in to the products that we are manufacturing at our end. So there has to be an assimilation and integration of data. And also the data coming from suppliers might come in different forms. It might be an Excel, a PDF, a digital format, etc., etc. There is an extremely important need to have an interoperable mechanism which can facilitate and harmonize the communication across these different formats, ensuring the data privacy and security. Because we do expect some of the, let's say, partners, entities will be extremely skeptical of sharing that data, because for them it's a sensitive information. And finally, when we're able to do all of this, it, although it comes as a last step in the end-to-end process, but it is actually, which kind of runs parallelly, is not to lose our sight from the emission reduction action plan, because that is what is actually going to demonstrate the reduction. So these two things actually go in parallel. We start the computation process, but at the same time we start engaging with our suppliers, and we will probably need to look at the different specific categories, supply wise, geography wise, a customized reduction roadmap and execution of that roadmap, so that while we are collecting the data, the reduction is actually getting reflected into the product carbon footprint. So with that, Alessandro, I hand it over back to you, and I hope I wasn't too long in my session.
Thank you very much, Kanish. Very insightful presentation. There were also already some questions. Perhaps you can scroll through, and in the meantime, I will share my presentation. Looks like it's different than just a second, huh?
Don't worry, we know technology is always not our best friend when we need it.
Now, is it coming over?
It's visible.
You
It's
see that?
visible. It's visible.
Okay.
Perfect. And you also don't have share my screen tags, so great one.
Thank you very much. Please alert me if there is something going wrong. Okay, so first of all, what will be the topic of my presentation? I will definitely focus on the importance of collaboration within an industry to address the topic of accurate determination of product carbon footprint, or as accurate as possible determination of product carbon footprints. And I will delve into the concept of standardization, because if you share data which are not anchored on clear standards, you will end up in a situation where you compare apple to oranges, and indeed you will only generate a lot of confusion in the supply chain. So let's start with an introduction of the association that I'm representing today. Here is Together for Sustainability, and it's an association of chemical enterprises, global chemical enterprises active in many value chains. 55 members. You can see the logo in the slide. They all in total represent a significant cross-section of the global chemical market, approximately 20%. And it's an association with a global, I like to say, handprint in this case, and not footprint, so a global handprint with chapters located in the various regions of the globe. But let's now describe what TFS has been doing on the topic of Together for Sustainability. And let's always start with the why. A couple of years ago, the members of Together for Sustainability, so all chemical enterprises, as mentioned, were basically realizing that they all had the same challenge. They all had the issue of needing to tackle sustainable transformation and the topic of scope 3 and in general carbon footprint reduction, since the chemical industry is a large emitter, or a large emitting industries. It was also clear to all the companies that a significant portion of the carbon footprints of every company is still located in the supply chain, so in the upstream part of the supply chain, but also the downstream part. But let's focus on the upstream part. And it was so clear at the same time that there were no sufficient prescriptive standards out there to determine a product carbon footprint for a chemical product. There was a lot of uncertainty in the supply chains about what would be an accurate value to be used to set up a meaningful LCI inventory. Therefore, the industry basically decided to deep dive into this topic and develop together a standard to make clearer how a product carbon footprint of a chemical product should be calculated, and many more things. Let's move perhaps to the next slide to outline what is the greenhouse gas management program that TFS has launched a couple of years ago. This slide summarizes everything fundamentally. You can identify here 5 key elements of the greenhouse gas program of Together for Sustainability. So the first step that was taken is to develop a standardized calculation method, which is very specific for chemical products. The second step was, okay, now we have a clear way to determine product carbon footprint. How do we exchange data among companies and avoid a situation where every company has its own questionnaire to ask for the same type of data? And therefore, a TFS data model for product carbon footprint has been developed to structure such queries along the value chain. Third point was, okay, and there was some of the question I saw in the slide. Sometimes I get data, but can I trust those? And what are possible definition of level of trust of a product carbon footprint. And here, Together for Sustainability collaborate with another initiative to issue a verification framework. We will get into that later. Fourth step, okay, we have now all these standards, but then how do we empower and train the supply chain to be able to follow such standards? And a series of valuable training sessions have been created in the TFS Academy exactly to achieve that. Finally, Together for Sustainability also joined forces with a tech provider, Siemens, to launch a digital data sharing solution to enable companies, members, but also non-members, to exchange product carbon footprint data in a secure way, in a standardized way, and follow with the guideline. All these ingredients are fundamentally a great enabler to eventually enable companies then to focus on reduction of product carbon footprint and make such reduction visible in the supply chain in an accurate and trustful way. Let's now try to give a little bit more context and in all these points. You remember the first step was developing a guideline. There are, of course, quite a number of standards available for product carbon footprint calculation, like the ISO 14067 or the Greenhouse Gas Protocol product level, or also the PAC framework. The point that these standards have been developed to cover a very large cross-section, actually are designed to cover all possible markets and all possible products. This comes with some limitations, of course. Such generic standards lay the groundwork of the PCF determination, but cannot get into the specifics of the one or the other industry. And here is where sectoral guidelines, like the guideline of Together for Sustainability, can play a role, right? To add a layer of prescriptivity and specificity in order to enhance the comparability of product carbon footprint, which are eventually calculated. That's basically how you could position the TFS guideline among other standards available. You can see this pyramid on the left side, right? So generic standard at the bottom, sectoral guidelines in the middle, and then the sectoral guidelines like the Together for Sustainability can positive list even more precise rules for specific product groups, the so-called product category rules. It is one thing is in any case very important in this approach is that you keep anchoring to the generic standards and you are interoperable with other sectoral standards, and that's been quite heavy involvement of Together for Sustainability in engaging other similar initiatives in other sectors like the automotive industries or the pharma industries or other industries in order to achieve interoperability of methodology and also data models between sectors along the supply chain. Talking about technical interoperability, fundamentally is having clear data models to standardize a product carbon footprint communication between companies. As mentioned, it makes no sense that on the same topic, product carbon footprint, different companies use different questionnaire to ask for the same piece of data. Here, standardization provides huge value to simplify the work and reduce complexity and bureaucracy, basically, also in the supply chain and this type of processes and data collection processes. The data model of Together for Sustainability has been also aligned and is kept aligned with other data formats and data models, like, for example, the PAC framework data model. Let's move now to the other area of work of Together for Sustainability. which was also, if I recall correctly, one of the questions appearing already in the chat. How can I trust the data that I received from my supplier, from my supply chain partner? What are the indicators that can help me to judge whether this data is something that I should or I can bring in my inventory, in my data inventory? And here definitely on one side, data containing the data model, like the data quality rating or a primary data share, can help in form of self-declaration to assess whether a piece of data or product carbon footprint has an adequate level or a good level of quality when it comes to technological representativeness or time representativeness or geographical representativeness. But in the end, a self-declaration comes with a limit. You may need to have a verification framework in place with third party involved also to assess whether a product carbon footprint has been calculated according to a specific standard as declared. And here, the verification framework that Together for Sustainability has developed together with the automotive industry and the initiative called Catena X, but also significant representatives of the auditing and certification industry like Deloitte, PwC, and TÜV SÜD, has been exactly the development of a so-called verification framework, which describes very precisely how the PCF verification process for chemicals, but also for components of a car, but it can be used also in other sector, should be performed, and also assign or define layers of trust, from a very basic layer of trust, like a completeness data set check, to a high level of trust, like a third-party verification and auditing of a concrete product carbon footprint data set. But you also have some intermediate level of layers of trust, like a product carbon footprint program certification. So a third-party company having certified and checked whether a company has a product carbon footprint calculation program in place, similarly as what Kanish showed in his presentation, and whether that program calculates product carbon footprint according to the declared standard. All these verification framework KPIs are contained in the data model that we showed in the previous slide. So next topic of work of Together for Sustainability was developing a TFS Academy, or a series of courses on PCF calculation at TFS Academy, which are accessible to members and supplier of members of Together for Sustainability, and can provide in multiple languages a lot of help to company with perhaps less experience or little experience in the topic, to onboard and start to calculate product carbon footprint. Perhaps not being perfect from day one, but starting in the journey. With all this then in place, the next stage is, okay, I have product carbon footprint. I know how to calculate them. I have a standard which is prescriptive enough to do so, but I want to exchange them according to the data model that has been defined, and I want to do it in a safe and in a safe way, right? In a digital way, and ideally using a tool with many other companies are also using. And here, Together for Sustainability has joined forces with Siemens, and as we can say co-developed, co-launched a so-called product carbon footprint digital data exchange solution, which now TFS members are using to an increasing extent, to request product carbon footprint from the supply chain and provide product carbon footprint calculated to the customer along the value chain. This tool has the advantage of being interoperable with other similar tools, right? There are also other data exchange solutions in the market, according to the PACT framework or according to the Catenaix framework. With that being said, I would like now to add a few. Just sorry, I think that's. I hope that is the. Do you still see my screen? Okay, fantastic.
Yes, Alessandro, we see.
Something has changed on my screen, but great that it's just
No
me.
worries.
Here you see a snapshot of the Sea-Green Data Exchange solution of Together for Sustainability, which enables companies, as said, members and non-members to interoperably exchange PCF data. The tool is accessible to companies for basic activity, even for free. And in case you're interested about that, do not hesitate to contact TFS or also directly Siemens. And last but not least, any standard, any practice is valuable as long as it's used. And no standard will be used if it's not known and recognized in the sectors which are relevant in the supply chain. Therefore, a lot of efforts have been put in Together for Sustainability to engage with multiple industry associations, sector associations, and initiatives like PACT, Catenaix, but you can see here many other examples here in this slide, where other relevant sector needing chemicals, needing data on PCF data on chemicals in order to calculate product carbon footprint of finished goods or semi-finished goods, and therefore appreciating the existence of standards for data exchange and data calculation of product carbon footprint, like the one of Together for Sustainability. Before now moving to the question phase, I would like to highlight the last slide. And by the way, you will get access to all this presentation material later on, which summarize everything and provide you access to all the relevant content that I was illustrating, to a very large extent, all available for free. And can be downloaded very easily from the websites of Together for Sustainability, be it the guideline, be it the data model, or even training materials, etc., in order to help you to get onboarded on your journey to determine product carbon footprints. Thank you very much. I'm happy to have the Q&A session now started together with Kanishk. And let me see.
Thank you, Alessandro. It was extremely enriching, and every time I hear you, I learn something more, or at least it gets clarified in my mind. So thank you for that an enriching presentation.
Let's look into the question now.
Yeah, we did had some questions, as you mentioned. I tried to respond to them, but I think it'll be good to have your perspective as well on some of those. So, and also to the audience, if you can, please do not hesitate to unmute and ask the questions. But if not, please feel free to type in. But I think, Alessandro, we can look at the question which came in from Dagny, which talked about, let me go in there. How do you handle the difference between the secondary emissions and the site-specific PCF? And there were some related questions as well, which spoke about the nuances and whether should we wait for the precise data or not. I think you touched upon that as well. I've also tried to respond, but I think it'll be good to kind of reshare what our view is on the granularity of the data.
Yeah. First of all, if the question is related secondary or primary data, it's very obvious that right now you don't have data available for all products in the world, right? For all raw materials that you purchase.
Yeah.
So at this moment, every company, and that includes BASF, or includes certainly also the case of Schneider Electric,
Absolutely.
and you need to go hybrid, right? So you need to work with primary data, but also secondary data. And in some cases, secondary data from data banks are not even sufficient, because you may have some more exotic raw materials or more exotic inputs which are not available even in the data banks.
Yeah.
Then in those cases, you will have to use proxies, right? All this is perfectly fine. So by the way, it's also absolutely tolerated even by the regulators. Important is to declare exactly what you do, right? Important, and you have some KPIs, for example, to track your primary data content, and to track and declare the quality of the data that you have. And of course, if you use a proxy rather than perhaps even a verified data coming from your suppliers, then it will make a difference, obviously, in the type of quality of data that you're handling. At the end of the day, if you want really to drive real reduction, there is basically no better alternatives than go towards primary. Because if you deal with primary data from your suppliers, you can ensure that the data is not just averaging out all supplier of that particular product, but that is exactly the emissions level of your suppliers. And then you can track much better the improvements of that supplier, or the improvement that you can achieve by switching suppliers.
Absolutely. Thank you, Alessandro. And actually, what you explained kind of covered some of the other questions as well, which talked about certain materials not being included. So it kind of gave an overall approach on how to look at it. So it's a journey of exploration. We don't wait for precise answers. We keep on moving with what we have, at the same time trying to be more efficient in that journey. So I guess that's the key message which comes out of the entire exercise.
Exactly. And by actually tracking the mentioned KPIs like primary data share, data quality rating, and so on and so forth, you will also be able to measure how the quality of your data and how the level of primary data content will improve and increase over time.
Absolutely. There was one more question. I don't see any more fresh questions coming in, but it actually dealt with what should be the typical frequency of collecting. Although I responded, but I think it's important for the audience to hear from your perspective as well on what is there any ideal frequency, or we just get it once and we are done for life. I hope that's not the case.
I noticed also there was a question on restatement requirements, right?
Yeah.
But first of all, my recommendation would be, and hopefully it's the same as what you also provided, it's better to do it more frequently right now, because data quality improves quite dramatically these days. And secondly, because companies are starting, or in some cases already quite advanced on their decarbonization journey, and therefore right now the big steps of improvements can be visible, right? And asking more frequently, let's say once a year, product carbon footprint for your suppliers will show gradual and even step improvements in some cases. Technically, I think that every company should have a policy how often PCFs are recalculated and exchanged and requested. should have also a policy of a restatement of carbon footprint in case changes or proactive statements of PCF data changes if the change exceeds a certain thresholds. The guidelines, for example, the TFS guidelines or also other guidelines provide guidance also how the threshold should look like. For example, the TFS guideline mandates proactive communication of a PCF change to the customer if the PCF has changed more than 20%, and the other threshold, it shouldn't be older than 5 years, and if the PCF gets older, the quality rating would also be affected, right? Because temporal representativeness is an indicator of how fresh or how old the data are, which have been used to calculate the product carbon footprint. Also important to be said, secondary data sometimes even they tend to be updated with certain frequency. They may be based on older data sets. Therefore, it's also another reason that primary data can help to get more accurate and fresher data in your inventory.
Perfect. Perfect. Thank you so much, Alessandro. And I think we're also on top of our time. We would not like to make life difficult for our friends in SPP because they've got a schedule to run over. So I think we can conclude the session. And thank you so much to all the people who participated as the audience. I hope you enjoyed, and we hope you enjoyed the session as much as we enjoyed presenting it to you. Thank you.
Thank you, Kanish. It was really fun to have a panel with you.
Likewise, Alessandro. Have a good rest of the day. Bye-bye.
Thank you. Bye-bye.
Hi everybody out there, my name is Florian Former and I work for Bayer. The Sustainability Procurement Pledge is a crucial initiative for us as it represents a commitment to shape procurement as a profession and to address significant global challenges. What I do like in particular is the fact that it's done from procurement for procurement, which I think is a really cool thing because we can learn from each other and do better. So by prioritizing sustainability, we all over the world can influence entire supply chains, promote ethical practices, reduce environmental footprint, and foster social responsibility. This pledge empowers us to generate an impact that extends far beyond our individual roles and is making procurement a key player in transforming the world.